All right, so we're going to talk about the algebra of functions, and I have several examples lined up, but each example is going to be in a different video. So this is the first one. F of x is 3x squared plus 2x plus 1, and g of x is x squared minus 4. Now, both of these are polynomials, so both of these have domain of minus infinity to infinity, or all real numbers. When we add, subtract, and multiply functions, these are all going to have the same domain. Okay, and the domain is going to be anything that you can't use in F, you can't use in F plus G. And anything you can't use in G, you can't use in F plus G. Same for F minus G and F times G. So you kind of overlay the domains, and anything that can't be used in either one has to be thrown out. This one has the same domain as the others, in addition to G, or the denominator, can't be 0. So we need to find the place where the denominator is equal to 0 and throw out those numbers, and in addition to all the numbers that you can't use originally. All right, so let's look at the algebra of functions. So here we're going to start off by looking at f plus g. And all that means is we take f of x and we add it to g of x. Okay, since it's addition, I can drop off the parentheses. I'm going to combine like terms. So I get 3x squared plus x squared plus 2x, then minus 1 minus 4. So I end up with 4x squared plus 2x minus 5, and the domain is all real numbers. And that's going to be the domain for the next two as well. Now I'm going to look at f minus g. So I get 3x squared plus 2x minus 1 minus x squared minus 4. Now I need to, so the parentheses are very important. We didn't need them in the first one, but we definitely need them here, so we need to pay attention to that. We need to distribute the negative. So we get f and then minus x squared plus 4. So we distribute the negative. And so 3x squared minus x squared is 2x squared plus 2x, and then minus 1 plus 4 is plus 3. So we get 2x squared plus 2x plus 3, and our domain is all real numbers, because that's what it was on the last example. Okay, now we're going to look at f times g. And so here I definitely need parentheses, 3x squared plus 2x minus 1 times x squared minus 4. Now the way I'm going to do this, I'm going to take this to each number in the parentheses. So I'm going to go this way. So x squared times 3x squared is going to be 3x to the 4th, because I add 2 plus 2 is 4. X squared plus 2x. And fortunately multiplication is here is commutative, so it doesn't matter. Whoops, I really wanted to write that here. And like 2x times x squared is going to give me 2x cubed, because that's a 1 plus 2 is 3. And then I get minus 1 times x squared, so minus x squared. Okay, now I'm going to do this with the 4. So I get the minus 4 to each one of these. So minus 4 times 3x squared. So that's going to give me minus 12x squared. And then minus 4 times 2x is going to give me minus 8x. And then minus 1 and times minus 4. So minus 1, or minus 4 times minus 1 is plus 4. And we only have two like terms, and that's minus x squared minus 12x squared. So I get my final answer. My simplified answer is 3x to the 4th plus 2x cubed minus 13x squared minus 8x plus 4. And my domain is the same as the previous two examples. All right, next example, f of x, f divided by g of x. So I take f of x and divide by g, which is x squared minus 4. So I get the same domain, except this cannot equal 0. So I look at, so this thing is a rational function, so it kind of becomes a rational function. Well, it does become a rational function. So we get x squared minus 4, and so what numbers have to be excluded? So x squared minus 4 factors into x minus 2 times x plus 2. And so x can't be 2, and it can't be minus 2. Because if we had 2, we'd have 2 squared minus 4 is 0. And if we had minus 2 squared would be plus 4, and then we'd have plus 4 minus 4 is 0. So we can't use either one of these. So our domain, well, let me draw the real line here. So here's minus 2. We draw an open circle on it to remove it from the domain. So we use everything to the left of minus 2, everything between it, between minus 2 and 2, and everything bigger than 2. So that is our domain for this problem. All right, and that's, well, I guess let me add one more example on here. We can also have g divided by f. And so that would be x squared minus 4 divided by 3x squared plus 2x minus 1. And now I need to know when this is equal to 0 so that it cannot be 0. I can say don't let that equal 0. So this is kind of, so I need to factor this one, and so it's going to factor, 3 has factors 3 and 1, and 1 has factors 1 and 1. The 1 is negative, so I know one of them is going to be positive and one of them is going to be negative. And then the 2x means the bigger one's going to be positive. So if I take 3x times 1, that's going to give me 3x. And then minus 1 times x is going to be minus x, which combines to give me the plus 2. So let's check it. There's 3x squared plus 3x minus x minus 1. So that is what we started with. So x can't be 1/3. So take 3x minus 1, and we don't want it to be equal to 0. So add 1. And we get 3 x equals 1, divide by 3, and we get 1/3. So when x is 1/3, this will be 0. So don't let x equal 1/3. And then when x is equal to -1, this thing will be 0. So don't let that happen either. So our domain ends up being from -infinity up to -1, since it's smaller. Think about the interval. I'm not drawing it or the number line. I'm not drawing it this time. But still think about the number line. -1 to 1/3, union 1/3 to infinity. And that is my domain. So G over F gives us a different function and different domain than F over G.